In this video lesson on analytical geometry, we are going to look at the midpoint. Now, an overview is we're going to look at the midpoint formula first, and then we're going to look at some examples. Now, to start off, we'll look at a Cartesian plane, and on this Cartesian plane, we'll just put two random points, okay? And we're going to name the one point A, and in terms of x and y, xa and ya, and then the other point we're going to name B. So we can connect these two points with a line. But what we want to find is basically the midpoint, so the point that's exactly in the middle of these, and we can call it M, xy. Now, we want to find the value of x and the value of y basically in terms of A and B's, x and y coordinates. Now, to do this, I'm going to follow just a procedure just to show you how it is derived. And to do that, first I'm going to decompose the line. So we've got this slanted line, okay? And if we decompose it, we've got the y values here and the x values over here, okay? And we're going to do that to only focus on the midpoint between the two x values and then only the midpoint of the two y values. So we want to find this coordinate over here as well, and this line we've constructed in such a way so that that it goes parallel to the y-axis, meaning that this point over here will lie directly underneath A, which makes the x value of this point also xa, okay? And the same here. This line is parallel to the x-axis, which makes it in the same fall in the same plane as yb. So the y value of this point will be the same y value as b. So that coordinate is then xa, yb. All right. Now next, we can basically find the midpoint between these for this line. Okay, a midpoint for this line, and we're going to construct two more lines. So we're going to construct that line and that line. Now, there is like a formal proof to actually prove that this is the midpoint of these 2 points, okay? And it should be in your textbook. I'm not going to go through that proof now because you don't really need to know the proof. But what I am going to do is basically to show you how we do find the midpoint, because I think that will give you more insight and help you to remember the formula. So the proof, basically, just to run through the proof, what the proof does basically. The proof basically just says that these two triangles, they prove these two triangles congruent to each other, okay? So meaning that if these two triangles are congruent, these corresponding sides must be equal to each other. Then also we've constructed these lines in such a way that both of these lines run parallel to the x-axis and both of these lines run parallel to the y-axis. And that makes this a parallelogram. And if this is a parallelogram, then the opposite sides will also be equal. And that means that if these two sides are equal and the two corresponding sides of the triangles are equal, it makes this line equal to this line, which means that this point over here is then the midpoint between these 2 points. Okay, so this point's coordinates, let's look at that point's coordinates. We want to find the coordinates, and why do we want to find it? Because we know that the x coordinates of this point will be the same x coordinate of that point. Then we've basically solved for this x value. So to find that x value, or let's actually start just with the y value. The y value is in the same plane as this point and b, which means they all have the same y value. So that would also just be yb. Okay, that's pretty easy. But to find the x value, it's exactly in the middle of 2 points. And you can think of it in one of two ways. You can basically find the average between the points, okay? Or if you just want to find the midpoint of any 2 points, you add them together and divide it by 2. So we're going to say, okay, take xa plus xb and divide them by 2. And that gives you the x coordinate. So this coordinate over here will be that x coordinate. And similarly, if we want to find that point, we know what the x value is. The x value is just the same as xa because it lies directly underneath xa. So this is xa. and the y coordinate will be the middle point between ya and yb. So we're going to add them, ya plus yb, and put it over 2. And that is going to be the same as that y value. Okay, and this is basically your formula. So you have that the midpoint of x and y is, then replace that with this formula, xa plus xb over 2, and this side, the y coordinate, is ya plus yb over 2, and that's it. All right, so now let's look at how we're going to use this formula. So the first example says, calculate the midpoint of the line segment joining A and B. Now, if they don't tell you what the coordinates is of, or the value, not the value, like for example, this coordinate is A, that coordinate is B, what is the midpoint? So then you just name it M. Okay, so M is then the coordinate itself. So the formula goes inside the coordinate. It says x of A plus x of B over 2, and the y coordinate is y of A plus y of B over 2. Okay, so inside the coordinate, we substitute in the values of A and B. So we have that M is going to be minus 1 plus 8 over 2. And then for the y coordinate, we've got 2 plus 0 over 2. And then we just simplify. So M is 7 over 2, and 2 over 2 is 1. Okay, now when we do this, you can put this in decimal places, but when you work like with analytical geometry, normally leave your things in fractions. It's just easier to work with that, especially if you have follow-up questions and everything. But if you have a final answer, especially like distance, you put that into 2 decimal places. But normally, for other things that you are working with, just leave it as this. Okay, then for example 2. Now calculate the value of x and y if C is the midpoint of the line joining DE. So in this case, we've got a line DE, but now we know what the midpoint is, but we don't know what one of these 2 points is. So let's just draw it to get a clearer understanding of that. It's not according to scale or a right or anything. I'm just drawing a line with a midpoint. So this is going to be D, minus 4 and minus 1, and this is going to be E, which is x and y, and then this is going to be C, which is minus 2 and 1. Okay, so now we know the midpoint, we don't know one of the other points. Okay, so we're going to substitute everything into the formula, what we know, and then also what we don't know in terms of x and y. So if I want to substitute in the midpoint of C, okay, that is going to be basically the x value of D plus the x value of E added together, divided by 2. So this would be minus 4 plus x over 2. Okay, so just in terms of x, because I don't know what x is. And then y for D, so minus 1 plus y over 2. Okay, so this is now the midpoint formula, but now this must be equal to the actual value. This must be equal to C's minus 2 and 1. Okay, so meaning that this, just to put it in a different color, let's just use, we can use red. This must be equal to that. Okay, and then this must be equal to that. Then we can solve x and y with those 2 separate equations. So I'm going to say that minus 4 plus x over 2 is equal to negative 2. Okay, to solve this, I'm going to start by multiplying or cross multiplying, multiplying both sides by 2. Minus 4 plus x is equal to negative 4. Take the 4 over to the other side, then we have x is equal to minus 4 plus 4, and this is 0. Okay, and then on this side, for the y value, we do exactly the same. We've got minus 1 plus y over 2 is equal to 1. Cross multiply or multiply both sides by 2. Then that leaves us with minus 1 plus y equals to 2. Take the 1 over, y is equal to 2 plus 1, and y is equal to 3. Okay, and that is our answer because the question just says calculate the values of x and y. If you want to, you can basically just say, therefore, the coordinate of E is 0 and 3. But just notice, if they do say in the question, calculate the coordinate of E, then you have to put this final answer. All right, then that was example 2, and then we're done with this lesson.